Hello and welcome. My name is Sean Hull, and I am a business and technology consultant, author, and speaker. I am the founder and senior consultant at Heavyweight Internet Group in New York. For the past 12 years, I have consulted with various startup and Fortune 500 companies, and I specialize in troubleshooting complex web applications that use Oracle and MySQL databases. Today I will narrate and present Philippe Campos's slide presentation on the MySQL database architecture. This presentation gives a simplified description of the MySQL architecture. It will put forward the most important points that need to be understood to install and tune your MySQL server. Your MySQL server runs on either Solaris, Linux, or Windows. The MySQL architecture is the same on all of these systems. MySQL is a relational database management system composed of 3 layers, a 3-tier architecture. The first layer handles and manages connections to the server. The second layer analyzes, optimizes, and manages queries that are sent to the server. The third layer is made of multiple storage engines that read and write data. You will choose one or several storage engines that suit your needs. Each server connection is a thread to which MySQL assigns memory buffers. The read buffer size controls the buffer for sequential scans. The sort buffer size controls the buffer for sorts. Temp table size controls the maximum size of temporary memory tables that are used for group by operations. Those buffers are dynamically allocated during query execution. Which clients can connect to the MySQL server program? The MySQL interactive client provided with the distribution can connect, as well as any client using either ODBC or JDBC standard to communicate with the server, as well as PHP. Under Windows, local clients can connect using shared memory, NT pipes, or TCP/IP. Under Linux and Solaris, local clients can connect using Unix sockets and TCP/IP. With all systems, remote clients connect through TCP/IP protocol. The second layer is the SQL engine. This layer performs 3 functions: saving to and fetches from the query cache if it is activated, query analysis, and query optimization. The third and last layer is composed of storage engines. Among the most commonly used, MyISAM, InnoDB, and Memory. The high availability engine called the cluster or NDB engine as well. There are also others such as the merge, archive, and federated engines. That's the feature that really differentiates MySQL from other relational database management systems. You can choose in a single database to use the MySQL engine for some tables, to use for others InnoDB, and for still others the memory storage engine, and so on. 2 points to help you decide which is the storage engine that fits your tables best. Do we need transactional capabilities? Which grain of locking is required? A change to the content of the table is called non-transactional when you never need to roll it back. The MyISAM engine is perfect for this type of change. A change to the database is transactional when it can be undone. With databases, one says rolled back. For this type of change, the InnoDB storage engine is mandatory. In a transactional environment, it is possible to group related changes to several tables into a single unit of work. You can either commit or roll back all of the changes at once. For these tables, the InnoDB engine is mandatory. MyISAM can handle 2 types of locking. Table locking. A user updates a table. The table is locked as long as the change isn't committed. Another user has to wait for previous change to be committed before he can in turn update the table. This is the way the MySQL storage engine works. Row level locking. A user updates one row while another user updates another row without having any of them that waits for the competition of the other operation, completion. This is how the InnoDB storage engine works. To summarize, the MySQL engine allows fast searches, doesn't handle transactions, and locks tables. The InnoDB engine works in transactional mode and locks rows. A few important remarks about the various files used by MySQL. The my.cnf file that is located under etc. under Linux contains system parameters, size of memory allocated to the MySQL buffers and size, etc. And the MySQLD log file records events in the life of the server itself, including errors when they occur. Finally, the description of all the files is stored in the .frm file. Thank you for your attention. I hope that this presentation will allow you to install and tune MySQL in your environment. Don't hesitate to get in touch with me by email if you wish. You can reach Philippe Campos at the email specified in the presentation, or you can reach myself, Sean Hull, at hullsean@gmail.com. That's HULLSEAN@gmail.com. Finally, I'd like to thank Stéphane Ferrou for his attentive and efficient help in making of this presentation. Thank you for your attention.